Hi, folks. Welcome to another example for our statistics class. We are still in chapter 1, and this is taking a look at determining the correct data type or identifying the correct type of data. And before we get into our example, what I want to talk about is just a reminder from our textbook. We learned that there's two different kinds of data types. There's a quantitative and a qualitative. And I know those words seem pretty similar, so let's break down what the difference is between those, okay? So a quantitative data type is nothing more than a data type that involves a number, okay? So it means that if whatever data I'm collecting, it should have a number in it. Now, in contrast, let me break that down for us. In contrast, we have something called a qualitative data type. And that one, actually another word for qualitative is categorical. And so I like to think that we have sort of categories of things that we are trying to explore, okay? So next to qualitative, let's write categories. All right, so one more thing that we should know is, aside from what we have numbers and we have categories, is that when we look at the quantitative ones, there's actually two different types of those. We could either have continuous or we could have discrete, okay? And so the continuous is more like you could have any number, okay? So it could be like 3.5, like a GPA. Or it could be 12.9 or 14.875. So those are examples of sort of a continuous number. It might have not a whole number. But our discrete numbers, those are ones that we tend to think of as whole numbers or counting numbers. So for example, if I said, how many fingers do I have? Well, I have 10 fingers. So that would be a counting number. It would be a discrete number of fingers. Okay. Now, if you're out there and you've had an unfortunate accident where you have lost part of a finger, maybe you don't have 10 full fingers, and that's okay too. But you know, we would measure that one maybe on more of a continuous quantitative rather than a discrete. All right, so let's take a look at the examples that we have here. And all we're going to do, we're going to write the letters in one of the two categories, depending on which one it is. All right, so the number of pairs of shoes that you own, I'm going to say that that's a quantitative because I have a actual number of pairs of shoes, okay? I probably have a shocking number of sneakers, so I don't really want to say how many I have, but I have a lot of pairs of shoes. And so when I think about that and I'm counting these, I know that it's going to be a discrete quantitative measure, okay? All right, next up, the type of car you drive. And so a type of car is not going to be a number, right? Like I don't drive a 5. I might want to drive an M5, but I don't, right? So we don't typically assign numbers with cars. We think about it as a category. And so that would be a great example of a qualitative measure. Okay, next up, the distance it is from your home to the nearest grocery store. So I know that that distance, whether we're measuring it in miles or kilometers, is a number. However, chances are we don't live like a whole mile away. We probably live like 2.75 or something like that. And so that would be what we categorize as a continuous quantitative number, okay? All right, D, the number of classes you take per school year. It's a number, and we can't really take half classes. We might put in half effort in some of our classes, but we don't take half classes. So that is going to be a discrete quantitative data piece. All right, the type of calculator you use. Now, some of us might be fancy. We have the TI-84. Even though there's a number in there, that's a category. It's a type of calculator. So E, that type of calculator, is a qualitative piece of information. All right, F, the weight of dogs at an animal shelter. I'm definitely a dog person. I don't know how many of you are cat people out there. You know, good on you, but I like the dogs. But the weight of dogs at an animal shelter, we know that that's a number, but that is going to be continuous, right? We don't say that dogs have to be whole number pounds or ounces. It's just some sort of like, my dog is 39.5 pounds. Weight of dogs at an animal shelter would be a continuous quantitative data value. All right, G, the number of correct answers on a quiz. That is going to be a number. And as we're not talking partial credit, right? We're not talking about how correct they are. We're just saying how many you got right. And so that is going to be a discrete quantitative measure. And last but not least, we're going to take a look at IQ scores. And so IQ scores, I think we can think about this in two ways. Some people may argue that it is a quantitative value because it's a number. And they only come in whole numbers. So maybe we say that they're discrete values. But I think it could also be argued that it is a qualitative measure because some people might sort of associate an IQ, like a certain number, with a category like genius level, something like that, right? And so I think all the other ones were pretty clear. Age could kind of go either way, and sometimes we'll encounter that. But yeah, this was an example I hope was helpful in figuring out the difference between the qualitative and the quantitative data sets. Let me know if you have any questions.